Hi GOR, this is Unit 4, Lesson 6, so this is the last lesson in this unit, and we're going to talk a little bit more about similarity criteria for triangles. We'll do another proof, and then we're going to talk about dilating circles a little bit. So in this first example, my triangles are similar to each other. Now if they're similar, that means that the angles are congruent, and that means that the sides are in proportion. So we're going to do a little bit of each with this problem. So let's fill in what I know. Let me make my pen a little bit smaller. So angle C is 120, so I'm going to put 120 in there. And angle F is 15, so I'm just going to draw an arrow. I don't think I can write a 15 in there. AB is right here is 20. EF is 10. AC is 8. Okay, and that's everything I know. So let me switch colors. I want to find angle E. Well, basically, if angle F is 15, that makes angle B also 15. And if angle C is 120, that makes angle G 120. Because remember, my angles are congruent. The corresponding angles are congruent to each other. So if I want to find angle E, well, the angles of a triangle equal 180. Right? All three angles equal 180. Angle F is 15. Angle G is 120. So let me add the 120 and the 15. That's 135. Okay? And the three angles together equal 180. So I'm going to subtract 135. And we're just going to ignore the phone there. So 180 minus 135 is 45. So that makes angle E 45. And again, it's because all three angles add up to 180 degrees. But I took an angle from the other triangle because I know those corresponding angles are congruent to each other. All right, second part of this, get a new color here. I want to find the length of EG. So I don't know what EG is. I'm going to call it X. But look at these two sides are corresponding. And these two sides are corresponding. Corresponding sides are in proportion. So I'm going to make up a proportion. I'm going to take the 20 and the 10, and I'm going to write them as a ratio, and then I'm going to write the 8 and the X as a ratio. Now, it doesn't necessarily matter which side is on top, as long as you're picking corresponding sides. So 20 over 10 equals 8 over X. Since I put the 20 on top, then you have to put the 8 on top because that is from the same triangle. How do I solve a proportion? I just cross multiply, and we're going to be doing a lot of this in the next unit. So 20 times X is 20X, 8 times 10 is 80. So to solve a proportion, you cross multiply, and I divide by 20, and X equals 4. All right, I'm going to try a proof with you again. All right, I know you don't care for proofs, and proofs are not your favorite thing, but we're going to do one more proof. So I want to prove that CD and AF are altitudes. All right, I'm sorry, that's the given. CD and AF are altitudes of triangle ABC. I want to prove that ADE, which I'll highlight right here in yellow, is similar to CFE. Now, if they are similar, I want to prove they're similar. In order to prove they're similar, I need angle. So that's my goal, is to get angle. All right, so I'm going to start with my given, that CD and AF are altitudes. Now remember, altitudes are the height of those triangles. Altitudes are perpendicular to the opposite side. Perpendicular lines form right angles, and right angles are congruent. So those are the steps that I'm going to be using. I also have these angles right here. I'm going to call them angle 1 and angle 2. Those are vertical angles. So that's something everybody should be able to say, that angle 1 is congruent to angle 2. And why? Because vertical angles are congruent. Remember, I'm trying to get angle to prove that these are similar to each other. Now, if CD and AF are altitudes, well, that's going to make angle 3 a right angle, and it's going to make angle 4 a right angle. But the way it works is that first you have to say that CD is perpendicular to AB, and that AF is perpendicular to CB. Altitudes form perpendicular lines, so that's definition altitudes. Once I say they're perpendicular, then I can say that angle 3 and angle 4 are right angles because perpendicular lines form right angles. It's a progression here. And once I know that they're right angles, then I can say that they are congruent to each other. Why? Because all right angles are congruent. Now remember, I was trying to prove that these two triangles are similar. All you need for similar is angle, angle, and I actually did it. I have the vertical angles, and now I have the right angles. So they are similar by angle, angle. We're going to talk a little bit about circles and dilating circles and circles being similar on the next page. I already did the construction for you. You can just look at it on my paper. It's nothing that we need to do. So I dilated circle O by a scale factor of 2 with OA being the center of dilation. So here's how I did it just so you can understand it. You don't need to do it. I have circle O that's on your paper. I extended the radius. I made it nice and long. And then I took my compass and I measured the distance of the radius. And then I came here to the side of the circle and I measured it one more time because I wanted a scale factor of 2. And that was my new radius for my bigger circle. What do you notice about the centers of these circles? They have the exact same center. And there's a word for that in math. All right, we call that concentric. But I got one more question. What's true about the radii? Radii is just plural for radius. It's 2 times as long. They have the same center, but the radius is 2 times as long. Concentric circles are circles with the same radius. I'm sorry, circles that have the same center. Circles that have the same center. The radius is not the same. So it's sort of like a circle within a circle. Here's a circle, here's another circle. All right, there's a circle within a circle. Now, we're not going to do 4 because that was another construction and that's kind of hard to do virtually. Here's all I really need you to know. All circles are similar. All right, if I have circle A and I have circle B, and maybe circle B has twice the radius that circle A is, they're going to be similar to each other. Right? Similar figures have the same shape but not the same size. The only thing that's changed is the radius. So the radius is the scale factor. All right? All circles are similar, and we will talk a little bit more about all these things tomorrow.